is in this.
Hello, everyone. Welcome to another K6 Office Hours. I'm Nicole van der Hoeven.
I'm Paul Baylog.
And I'm Mostafa.
You don't have a last name? Are you like Cher or something?
Yeah. So I'm Mostafa Moradian. I'm a senior software engineer at K6. And I'm happy to be here presenting about XK6 Kafka and discussing various, architectures and, event-based architectures, event-driven architectures and stuff. So yes, there you go.
Awesome. It's good to have you here. I think you've been on once before, right? At least once before. And I know we've been trying to get you back on to talk about event-driven architecture in particular. So really excited about that. First off, it might have been a few times. Mustafa's like a regular now.
I've been a DevRel, so you know.
Yeah. So we want to talk about something cool that just happened just yesterday. We released version 0.40. And here are the release notes. I'm putting them in chat. The main change is that now we have experimental modules, which I'm really excited about. Maybe you can talk about them, Paul.
Yeah, no, that's really one of the cool things. So this is going to be the process ultimately for any of the extensions to kind of be promoted into the core of K6. So by, with this experimental, import space, you can actually use, we have XK6 WebSockets, XK6 Redis, and then XK6 timers that you can just import them directly using the experimental, namespace, for lack of a better term. So yeah, so that's pretty cool because this is going to be the way going forward as well for, like I said, promoting all these things. So that's a big deal.
Check out the release notes, which is in the chat right now, if you want to know more, because there are a few breaking changes for some edge cases, and also native JavaScript classes support. So that's pretty cool.
Yes, the Goja update. Yeah.
Hola, Charlie. Vince Huang, also one of our coworkers, also wrote a blog post called "You Can't Just Buy a 9." I'm posting it in the chat as well. It is about how observability and reliability are not just a matter of buying a platform or buying access to it or buying a tool. It's not that easy, and it's a little bit more nuanced than that. So check that out as well. I really like the title too. Mm-hmm. So, Mostafa, let's jump into it. Tell us, what's the deal with event-driven architecture? How is it even different from, non-event-driven architecture?
Yes, okay. I'm gonna rely on your documentation for this because you're the expert.
Don't give away the secrets, Mostafa. This is totally impromptu. We don't have talking points or anything.
You can't have the backstage info. No.
You're just giving away all my secrets here.
Yeah, don't look at the person behind the curtain.
The bin, so.
Yeah.
Yeah. Anyway, about event-driven architecture, the main thing.
Do you want me to actually play the video first? Maybe that'll help.
Absolutely. Yes, please do.
So I found this awesome video from somebody else. We've linked to his channel in the description on YouTube down below. There's no relation here. I just found it while I was doing research that Mostafa alluded to, and I thought that it was a pretty interesting place to start.
First, let's get into the concepts. On one hand, we have an event. An event is basically something that happens. On the other hand, we have a command. A command is an order, a request that you have to another party to give you a response. An event can be communicated in the form of an event notification, and a command can be communicated also in the form of a message. These two things are very similar in terms of the information that they contain. And you can see that an event notification will also be referred sometimes as a message. In practice, you will see many people referring to both of these things as events. So this event or message have different characteristics, as we mentioned before. It could contain data associated with the event or the command, or it could just be a notification that something happened. Additionally, something that is very important is that it is immutable. This event is the base of what is called event-driven architecture.
So that was from a channel called A Dev Story. Mustafa, reactions? No words.
No words. Yes. So okay, let me just put it this way. Let's talk about the source of truth in software architecture. So what is the source of truth? In general, like old style, one would call it traditional software architecture, the source of truth is usually the estate, okay, which is different from the event. So it is said that a bunch of events comprise an state. Here I'm talking about the end state, not the in between or the middle states. I'm not talking about that, because that can also be a message, an event, or something, and it can also be in a state in the system. But I'm talking about the end state, and in a traditional software architecture, you're dealing with end states. This is what happens when you save data or persist data in your database. You persist the end state of actions in your database. The in-betweens are usually less important in the traditional sense. But nowadays, with the invention of cloud services, there are more demand for scalability, like high scalability, hundreds, thousands of microservices and services and stuff. And this traditional software design quickly shows its age. So when you want to scale, especially horizontally, where you add more nodes to your architecture, it quickly becomes hard to see how they're going to contribute to the end state that is saved on the database. You see, like for example, when you receive a message, any microservice can pick up the message, do some processing, pass it to some other microservice, and then at the end, save the end result, end state in the database. And there are a lot of protocols that help with this, these things and stuff. But the gist is, we are dealing usually in traditional sense, we are dealing with the end state, usually all throughout the system. So, for example, imagine a website. When a user clicks on something, like, I don't know, a category, this is a message. It instructs the server to take an action. So it's a call to action. And there's a state on this event. So the state is that, like, I'm here in this page. This is my, I don't know if it's, a single page application or non-single page application. This is my API key. This is my thing. And then please do something for me. And then you take all this state and you do something about it. You do process it. You fetch some data from the database, make another message, wrap it, and then send it back to the user. So another state. So the user is now in the next state in your application. So when they click another button that is in the second state, they're implying that they want to go to the third and fourth and so on states. So end states. And usually things are already computed for the user. But in contrary to this is the event-driven architecture, where the event itself is important, not the end state. As in, like, for example, user clicked on this and then browsed to this and this and that. So all these events, all these messages that are produced either for analytics, either for, I don't know, notification, either for whatever happens in the system. That event, that very micro event, I would say, would send a message to the server specifying that in this timestamp, this happened. Or in this timestamp, the user is requesting this. And then in the next timestamp, so on and so forth. So when the server receives all these messages, when there are a lot of services involved, each service can, fetch these messages independently, depending on the order. If the order is important or not, that's also another discussion. But different consumers, different microservices can receive those events separately, act on them, and then produce some other events. Those other events are also get picked up by some other microservices, so on and so forth, until there is an end result which is saved and persisted in a database or data store, and then the user receives a new set of events or an end state, this and or thing. So
it sounds like what you're saying is that the traditional way is very linear, like it goes from one to the other, whereas event-driven architecture is not linear. It's not really that it goes from state 1 to state 2 to state 3, but it's more, that's why it's called event-driven, right? These events are captured and set chronologically, so they're time-stamped as well. And then they don't necessarily dictate a particular flow. Is that right?
Actually, both. So in an event-driven system, the order, as in order in time order, is important.
Yeah.
But the order of messages might not be important.
Yeah.
So a message could be like further in time, but could be an action that can take place before this. So for this to be processed correctly. So it's not sync, rather async in that sense. So you have a few events in the queue, and then each of your microservices pick one or two or a batch of these events, and then try to do something about them. So they are time ordered, but they might not be necessarily ordered in the sense that they should happen one after the other. In the case that they are timestamped. Yes.
We do have a comment here. It's saying LinkedIn user here for some reason, but it is actually from Julio CA. Traditional is synchronous, event-driven are the opposite.
Yeah, it's definitely a little bit more like that. It's more, the traditional is the request response type of a thing. Whereas, with event driven, it's one of the best terms that I've heard for it is like, it's a commit log.
Exactly.
Jake Krebs, who is he's the one that, he was one of the original creators of Kafka, and actually became the CEO and founder for Confluent. But anyway, he had this great video out there, which I would recommend everyone should watch it. Seriously, it's called I Heart Logs. And then he goes through this process, and he really explains it nicely. But it's all this async. You're just emitting these changes as they happen. And then basically you don't care or know who's listening to those messages. They're just, anybody that's interested in that will pick up those messages and do whatever they need to do. So it's really cool in that respect, and that it really makes things, one of the big touting of it is, it removes the back pressure, because if you have a service that depends on service B, and then in the traditional, you have to call in there and say, hey, what's the state of this? What's the state of this? And then, do some caching or whatever. Well, you could be putting a lot of pressure on that service B. It may not be written that well. It may be written in, some language that isn't efficient. I won't throw shade on anything, but
Why not, Java ducky?
right?
Oh no!
but yeah, so you could inadvertently be bringing down another system, and that's where, with the whole reliability aspect, one system could be bringing down another one unknowingly. And yeah, so that's where Kafka and just event driven architecture in general kind of eliminates some of that and handles some of that back pressure. I started going into event sourcing, which is yet another thing, but I'll pause there.
No, that's awesome.
I'm kind of a messaging geek, so I get riled up about messaging. So
yeah.
Wow. Okay, good to know. I do want to say though that I think event-driven can be asynchronous. It doesn't have to be. It's not necessarily asynchronous.
Yeah.
It can also be synchronous. It is just one of the benefits that it can be asynchronous. So, question for you both. Is event-driven architecture always the way to go?
No.
There's never always.
No, there's no always.
Never always.
The complexity. So there are a lot of inherent complexity in event-driven architecture. Usually, like one of the main things or blockers to this is debugging. So when you have lots, like hundreds or thousands of microservices, it really becomes a bottleneck when you want to debug what happened in the system. If you don't have distributed tracing, if you don't have all these good monitoring and logging tools and stuff. So that's one of the things that comes to mind. Maybe Paul has something to add.
No, it definitely makes things a little bit more difficult, and then that's where tools like event tracing and things like that really help. But yeah, that's a completely different topic in itself. But yeah, it does definitely add some complexities, and of course, it's not the right solution in every case. Because obviously, if you have things that are transactional, say like bank actions, you have to be careful. High volume, perfect for event driven, but you have to be careful in how you handle your transactions. So that's one of those things. So event driven does bring in some complexities with that regard too.
Yeah, very, very good example Paul said about bank transaction. So if you have an event-driven system and you have events that are timestamps, the good thing about this is that you can replay the events. So when something goes wrong, you replay the event from the start of what happened, and then you get the end result by looking at all the events that happened in a chronological order. So that's a good thing about event-driven architecture.
That's
event
one of the
sourcing
things I love.
Yeah. Yes.
Yeah, the replayability. So yeah, you can go back in time. You can your Scooby-Doo time machine. You can go back in time and say, hey, let's maybe purge this table in a database and let's replay all the events from a certain point in time.
Exactly. But you cannot do that with the end state. So
right.
in a relational database, you usually have the end state saved. So you don't have what happened, but what was the end result, which is unless you want to use your RDBMS for event sourcing, which is
there's that's definitely
its own complexities.
Yeah, and that's actually kind of a trend that's coming along too, where like in the case of, don't want to really point out Kafka specifically, but for these event-driven systems, but Kafka, where Kafka is the database, that still makes me feel really weird. I'm of the thought that, usually relational databases are better, or no SQL databases. For those maintaining that end state, and that Kafka is the conduit to get the data there. But a lot of people use event sourcing where, Kafka is the database, and you continually pull the events and kind of have a cache everywhere.
I think what you're referring to kind of is the real-timeness of Kafka. So Kafka does things in real time. It has a streaming API, and it can show you time windowed results very quickly as the event comes in. But this doesn't happen with databases where you have to do some processing, apply some business rules, and then at the end I don't know, retrieve something from the database, store something on the database, and then return the result. So this whole flow of going to database and back kind of adds to the delay in returning the response. But that doesn't happen with Kafka usually.
So we have a question here from Gaurav Saini. What are trade-offs of event-driven architecture, which we've kind of touched on? One thing is, Mostafa has already talked about the increased complexity. This is also something that's based on microservice. Anything with microservices, obviously they have advantages, but any additional actor that you're introducing into a system could potentially lead to complexities around what's talking to what. And then also we've talked a lot about asynchronous processing, and that can also lead to eventual inconsistency, meaning that when there are multiple sources of data that multiple consumers are looking to use, then there is a possibility that they might get a little out of sync or out of order. Now, maybe that doesn't matter for you. For some use cases, maybe it doesn't. But if it does, it's a good thing to take into consideration before you fully switch to event-driven architecture.
Exactly.
I guess there is also a possibility for decreased performance. Not all the time. It's not inherent in it, but you are introducing like message broker, so that is an additional step, right? So potentially it could decrease performance.
Yeah, depends. But also one thing to mention is the complexity to manage these systems. So having a Borg, having a monolith is sort of easy to manage. So you scale it vertically, you add more resources, and it just handles the more resource you throw at it. But when you scale horizontally, so you should take care of interconnections, this mesh of services that you have, and a lot of things that are inherent in these systems. Like, for example, inside your services, you need TLS. Then you have to have service mesh, and management of these. And when they are killed, so then comes something like Kubernetes to manage all of this. And then Kubernetes itself is hard to manage. So it's kind of multiple layers of complexity adds on top of each other. And when you don't have enough manpower to manage all of this, so the DevOps part, the programming, the maintenance, the release, the deployment, everything, it quickly gets very hard to manage. So that's also another thing.
Yeah, definitely a lot of cognitive overload.
Exactly.
Oh.
So I think since we've already mentioned message brokers, maybe we can look at this video that explains what exactly these message brokers do. I mean, I think traditionally you could have, if you have two applications, they could just send messages directly to each other. So why do we need message brokers? This is a video from Kieran O'Donnell, again, link down below.
And so that first challenge that we had, if application 2 is not running, the good news is message brokers will have some form of storage. So application 1 can send that information as a message to the message broker. That message broker will store that up. And then when application 2 comes back to life, the message broker is able to forward on those messages to application 2. And this can give us some good reliability in our communication. The other challenge we had about the firewalls being in between, and so the message brokers can help us solve this challenge too. So we can put our message broker somewhere where it's accessible by both. So here message 1 can send a message out through its firewall, and we can see the arrow for application 2 now is connected the other way. They're both connected out into the broker, but that message is able to still flow through those two network connections. And the final challenge we talked about was, what if they don't speak the same language? Message brokers often can translate between different communication protocols. So here we see application 1 sending something in through HTTP. The message broker translates that and sends it down as AMQP to application 2, which can respond in AMQP. And then the message broker can translate that back to an HTTP kind of call and pass that information back to application 1.
Oh, yeah, he kind of goes into ESBs, kind of that where they're doing translations and transformations of data from one to another. Yep. That's another scary topic.
So I like that video clip because it really shows, we went into the disadvantages before we went into the advantages, but it's cool to see, like, he talks about outages in another application. If you just had one application talking to another and one went down, well, then that first application may just keep retrying that message, and that might be a problem, right? So having a message broker, having something in the middle means that message broker can be a little bit smarter about, when it actually retries things. Maybe there's like it waits a certain amount of time before sending everything to it. So it decreases the chances of like a retry storm.
Yeah, I mean that shows the back pressure, support or protection, I guess, because and that makes it where you can have your services being deployed at different times. That's in that outage. I'm going to say it's not because of a problem. It's because there's an upgrade going on. So temporarily that service that's being upgraded stops consuming messages from the message broker, but in the meantime they just continually stack up until that service is back online, and then it starts processing those again, which is a huge benefit, and especially with microservices again, because now you have so many more moving pieces in your overall architecture.
Yep. There's this thing that you mentioned, Paul, and also partially Nicole, the issue of queue buildup. So for some systems, queue buildup is fine because it means that some issue happened. Either the service is unresponsive, is died, or is processing a lot of messages, cannot accept more messages. But in some systems like us, where the timestamp is very important, and the queue buildup kind of causes instability in our system, in our reporting, in our insights, in our various subsystems we have. So queue buildup is kind of kills the user experience for us, for the user and also for us. So we should quickly attend to this issue so that we can add more resources or scale up queue so that we can handle the load very quickly. We are a performance testing software, so we should be performant enough to handle these kind of messages. And there are a lot of inherent issues with queues and message brokers and stuff, like more than once delivery, which is bad. Two consumers get the same message, and then one acts, one is not act, and then both process the same thing, and it causes inconsistencies in your database, in your end results, and also in the way, like for example, the user might receive a notification twice, which is usually.
So we've also gotten 2 comments already highlighting that this kind of architecture makes it really difficult for testers. So this is from Julio saying that it does make it harder to test from his personal experience. And Gabriel Nacimiento says, how should we define acceptable metrics for asynchronous and real-time execution for performance testing?
That's a tough question.
I think that there are different approaches to it. One is that you could break it down. Always try to break it down on a component level first. It would be very difficult to jump in. Let's say you're looking at the flow of traffic of one particular message, and it goes to 10 different components. Rather than just jumping in and testing all 10 from the beginning, break it down and do it one at a time, and then try to see if there are any issues without any of the other integrations. And a typical problem here is, how do you do that when it's already all integrated? And this is where mocks and sort of test doubles can come in handy, so you can kind of stub out the rest of the system that you don't care about. So I find that very useful to start with that. And then another thing would be, you can do end-to-end testing. Ideally you would build up from it, kind of like the chaos engineering method of increasing your blast radius. So start with the simplest ones. And if there are no issues, then make it bigger and bigger and bigger. And until you're doing some sort of end-to-end flow that incorporates that. And at each step of the way, check its performance.
Yes. I just also wanted to mention Tempo, Grafana Tempo, which is a distributed tracing product by Grafana, by us. And you can use that to trace the whole, flow of the messages that come to your system and gets processed. So there's this trace ID where you inject the trace ID into your request, and then you can trace all what happened to that specific event or message all throughout your system. And then at the end, you get a result back, which should probably have a trace ID, and then you can measure based on that. Yes.
So, Mostafa, let's get into Kafka, because that's why you're here. What makes Kafka so different? I mean, there are other message brokers like RabbitMQ, for instance. How is Kafka different?
It's the best one,
Well, okay, so that was office hours. we can say goodbye now.
Comments, but yes. So the good thing about Kafka, along with some other message brokers, is that first, it's open source. Second, it's distributed, so you can add a lot of nodes to be able to handle millions of messages per second. That's very important. That's hard to achieve in some other pieces of software. It is built for event streaming, so it has like native event streaming API that you can just connect your application and start streaming to it and start consuming those streams as you go. And it's high performance, so it's proven to be very performant, been tested by a lot of cloud providers, a lot of people, a lot of companies. So there you go. It's the best.
Yeah. But
very compelling argument,
Yeah. I was just going to add too, though, that, obviously messaging has been around for a long time. And,
Exactly.
Being an old person, I've been kind of in it for a long time. But yeah, you have things like RabbitMQ or, from Apache, there's also ActiveMQ and other things. But those are not, like what Mostafa said, they're not quite meant for distributed, which that's really difficult, and then therefore fault tolerant. Because there's the whole managing, like Diello was asking in the comments there about some of the ordering of events and the consuming of events and things like that. So it's very difficult. So that's where it's like one of those things. If you have one single node, you're going to have a RabbitMQ server and you only have the one. That's going to be great. And what's going to happen though too is that while those messages are persistent, meaning but they're short-lived, whereas in Kafka they're long-lived persistence typically.
Yes.
With RabbitMQ, I would consider it more task-based processing, meaning one service puts a message to say, hey, I just did this, and then somebody else picks up that message and consumes it so that no one else gets it. That's a P2P message, and then they do something with it, and then that message is gone from the system. Whereas with Kafka, typically that message will stay in the stream so that it could be reprocessed, using your Scooby-Doo time machine and come back to it. But
I think you already mentioned that. So Kafka has a commit log and is a write ahead log. So all the things that comes into Kafka is written in a chronological order where each event is kind of after the other and stuff. And this helps you persist your events, and in a case of a fault in your system, a restart or something, you replay the events from the offset that you lost contact with the service.
Mm-hmm.
And then you pick up from there and replay the whole thing, and voila, you have your end result and state and all the events already in the date I call it the database, but message broker.
Yeah, and I mean, and it's tricky too because with the distributed, it's partitioning, right?
Yeah,
So
exactly.
you're going to have a stream that's a kind of a, think of it as like a single queue that's going to be distributed amongst several nodes, several servers, potentially. So if you think about it, it's really just a file on the system that's appended to continuously. Well, with partitioning, you have to say that, oh, okay, based upon this message, everything for, this particular, I want to say like, I think of it as like a database table or something. So everything with that, I don't know, it's all about hashing the value, the key, so that it always goes to the same log file. And then your consumers, they are the ones then that keep track of where am I at in this stream? What is my current offset? Where did I read last? So that it takes that off of the broker. The broker just manages, where to put where to distribute messages in the, in the distributed file system, if you will.
Exactly. So producer and also message broker doesn't care about how the consumer is going to consume this data. So that's good.
Yeah.
Actually, completely decoupled, consumer and producer, and also,
watch the iHeart logs. It goes through partitioning for Kafka, which is actually, it's a very deep topic. But
would you be able to find a link? Because I think that would be useful for me.
Yeah.
And while he's doing that, let's watch this short video clip from Stefan Marek on what is Kafka.
So Apache Kafka allows you to decouple your data streams and your systems. So now your source systems will have their data end up in Apache Kafka, while your target systems will source their data straight from Apache Kafka. And so this decoupling is what is so good about Apache Kafka, and what it enables is really, really nice. So for example, what do we have in Kafka? Well, you can have any data stream you can think about. For example, it could be website events, pricing data, financial transaction, user interactions, and many more. Additionally, once the data is in Kafka, you may want to put it into any system you like, such as a database, your analytics systems, your email system, or your audit.
Yes.
So that was a quick, okay, keep going. You go.
Yeah, that was quick, very quick. I just wanted to mention that, like, on the Kafka website, so I might add it here. So
would you like to share your screen?
Oh, yes, please.
Yep, okay.
Please do. Yep. This is the Kafka website, the open source Apache Kafka. And as you can see, 80%, which is 80 from 100 Fortune 100 companies use Kafka, which is quite a big number. It's just the majority, basically. Majority by a huge difference with the others. So that kind of helps you get a better picture. But you might also say that, okay, so those companies have many resources. They have money, so they can throw at it as much as they can. But that's not necessarily true, because Kafka just works out of the box when you run it with the default configuration. So you don't have to do any shenanigans or have got powers to be able to run Kafka. And also there are a lot of cloud providers who has managed Kafka services. Also Confluent has a managed Kafka service, where you can easily just create an instance and start producing messages. And that's as easy as this. So just wanted to mention that. I think I've already talked about these capabilities of Kafka and its ecosystem and
actually, Mostafa,
how it can be used. Yes, please.
While you're sharing your screen already, could you show us XK6 Kafka and tell us all about it?
Absolutely. A very good idea. So what is XK6 Kafka? XK6 Kafka is an extension to K6 to load test Apache Kafka, not necessarily Apache Kafka. So my intention was not to test Kafka itself, because I know that Kafka is performant enough. Rather to test your consumers specifically, because this extension can help produce hundreds, if not millions, of messages per second if you throw enough resources at it. And it's written to support various serialization formats, so string, byte arrays, JSON, Avro, and possibly others in the future. And it also supports SAS, TLS compression. It also has a client for schema registry and beyond, as I mentioned here. So there are a lot of things involved. These are the supported features. If you want to have a look, maybe just show the URL to users if you want. But I think it's visible. Maybe let me show you.
I'll add it to the comments as well, so people can check out the repo.
Thank you. So let me go through the supported features very quick, and then I will show you an example of how it works. It has a producer, so it has 4 top-level objects. One is let me just show you on the code. It's much easier for me. It has 4 top-level objects and a lot of constants, which you can import from this extension. So K6X Kafka. So one is the writer. A writer is an object that can produce messages to Kafka. So you should create a writer here usually outside your default function or outside your view code in the init code. And then use that writer to write messages to Kafka, to produce messages to Kafka. So a writer is there to produce a message or produce messages, a lot of messages. The second high-level object is the reader, which is there to consume messages. They're fairly easy to configure, I would say. So you just pass in the list of brokers that you have, and then the topic you want to write to. So you can either set the topic on individual messages or at the top level writer. If you set it on the writer, you cannot set it on the messages, and vice versa. So they're mutually exclusive. Then you can also auto-create topics. So by default, the writer, if the topic doesn't exist, it won't create it for you. And it will create a lot of errors. You will see a lot of errors in your console. But if you enable this, then it will create the topic on the first message that it produces. And the last thing is that you can do like message compression. So it supports 4 different types that Kafka supports. So Snappy, LZ4, and 2 others, which I don't remember. But yeah, 4 different types of compressions, which we should also set when creating your topic. If you want to explicitly create a topic, you should also set the compression type to the compression type that you want the writer to write to. Otherwise, it's tricky. The second is the reader for consuming messages. So if you look at the reader is used to consume a message or a bunch of messages. The next top-level object is a connection. This connection is used for topics. So create a topic, list topics, and delete topics. This is a specific, separate connection. I'm thinking about refactoring this so that I can have a separate connection that can be used with writer and reader. But for now, it's what it is. The next thing that is recently added in version 0.13, if I'm correctly remembering. One moment. 14, sorry. In 0.14, I refactored the serialization and added this schema registry object, so that when you want, so everything is now explicit. Serialization, deserialization, and a lot of other things are now explicit. So you have to do it yourself with the configuration that you pass. So you no longer can rely on the extension to do conversions for you or serialize. I mean, it does the serialization for you, but you have to explicitly tell it to do serialize for you. Otherwise, it's raw messages coming and passing around. So just so you know. That's that. With the connection, you can create a topic. So here I kind of want to create a topic that is called xk6 _Kafka JSON topic. And I also set one config entry, which is basically telling the Kafka that messages on this topic should be compressed or are compressed with snappy codec. I also wanted to mention this specifically because previously, so there is a rewrite of the metric registry in K6 in the recent releases. And now all the metrics that are exposed by Kafka, now all of the metrics are exposed by XK6 Kafka, can be used to set thresholds and tags and stuff. So to keep that in mind. So for example, in this specific threshold that I set, I mentioned that I don't want any errors in reader or writer. So if there is an error, please fail this threshold. So the count should be always 0. The default function, please don't do this. I've made a bad example. Please don't do this. But since I want, oh God, yeah. Since I just wanted to make an example so I can like overload the Kafka service that I was running on my machine, I wrote this loop so that per each iteration, you see that there is 2 messages. So there is an array of messages. This is one message. And this is the next message. And the first message has, as you can see, has a key, which is, which has like, you pass an object to it. There's the data that you pass. The data should be in the format that you want, like byte array, string, or JSON, either of these. And then you have to specifically define the schema type or the data type in that sense. I couldn't find a middle ground between data type and a schema type, so I called it the schema type. This is a constant that is imported here. So you can import other constants. You can look them up in the API documentation. You can also have a value. By default, Kafka, keys are optional in Kafka, but values are not. So in this, because this is a test for JSON format, so I kind of created 2 separate JSON objects and then set the schema or schema to schema type JSON. I also set a header for this specific message and offset a partition and time. So these are the things you can set on your message that you want to produce. I cannot set, so you can also set the topic here. Oh, topic like something. But since we have set it here already, this will create a huge error message that says you cannot explicitly set a topic on your individual messages if you've already set it on your writer.
Right.
Yep. So these are mutually exclusive. The next one has also a key and a value, and it only has headers. So it doesn't care about the offset, the partition, and the time. So these are all set by XK6 Kafka. And in that loop, so per each loop of this, so I create 2 messages and 100, the index counts to 100. So 200 messages is produced per each call to Kafka, which I will show real quick after explaining these things. And then the reader consumes 10 messages, so you can set it to whatever you want. Here, for the test purposes, I set it to 10. Just one thing to note here is that the consumer is not written. I mean, consumer is there for you to test that you're producing the correct messages, but it doesn't necessarily mean anything, because you're testing your application, and your application are usually consist of consumers rather than producers. Producers are there, so you're already producing the messages here, so you want to see how your consumers, your actual application, perform when consuming messages. But for the sake of testing, I also included this. It has some internal issues because it's sync, and if you, like, for example, you set a limit of 10, and if you produce 9 messages, it hangs until the 10th message is in the queue until it continues processing. So just keep that in mind. And also, if the topic doesn't exist, it also hangs. So keep that too in mind. I mean, the producer itself might produce a lot of errors if the topic doesn't exist. So that's also something to know. You can also use checks to check the content of the messages and also the number of messages that are produced as outputted by the consumer. And as I mentioned already, since you are serializing the data explicitly, you have to also deserialize it explicitly. So that's up to the user to decide what they want to do with their data. If they want to process it as a string, or they want to do it as bytes or JSON. So it depends on the user. You can also, I will explain later, but you can also have schemas, and you can fetch schemas from schema registry, and then let it be deserialized with that specific, like Avril schema or JSON schema that is stored in the schema registry. Here's the content of the key and value. Here you check that the topic is correct. The headers are in order, the time, the partition, offset, and high watermark. And at the end, in your teardown, you probably need to delete your test data. So you delete the topic, you close the writer, the reader, and the connection. So that's about it. Let me just quickly show you how it works. So I've already done this. In order to compile XK6 Kafka, maybe I can just copy and paste it somewhere. So
Mostafa, can you also increase the
Zoom in?
font size? Yeah,
Absolutely.
thanks.
Is this good?
There we go. Yeah.
Way
Yep,
better.
Okay. So with this command, you can compile K6 with the XK6 Kafka extension. And since I've already done this, I'll just show you that. Okay, so there you go. There's a K6 that has, let me see, version 0.40 is recently released, but this is 0.39. So I will.
What? It's not an
Don't
experimental
want it.
module yet?
Yeah.
Is that what you were going to say, Paul?
Not about the experimental module, but yeah, you're not on the bleeding edge though.
Yeah, I usually am, but it kind of like this event coincided with this release. So anyway, so I already have, like, if I kind of, I have my Docker running, and I'm going to use Lenses.io, the fast data dev container, which I also mentioned in the README of, so here. So if you want to have your local Kafka setup, you can just copy and paste this in your terminal if you have already Docker installed, and then have a fully functional Kafka setup running in your machine. And maybe I can show you. Yeah, this is the Kafka development environment by Lenses.io. It shows that there are schemas, topics, connectors, and brokers, and the statuses are all green. And these are the service ports that are running on my machine. So the Kafka broker is 1992, and the rest. So just let me run this quick. I've already run this, so I don't need to. Maybe just okay, PS, and then there you go. I have it already up and running.
Nice.
Yes.
Yeah, I've never seen that particular image with all the setup like that. I guess that's a newer one, maybe.
Yeah.
But I
Yeah,
haven't looked
there's
in a
also
while.
another one. There's also
Yeah.
Wurstmeister, so which is this
Yeah,
one.
that's the one I'm familiar with. That was
Yes.
around a while back. But yeah, no, the Lenses IO looks pretty sweet, though.
Yeah, actually very nice. It helped me a lot.
Yeah.
Thank you, Lenses.io.
Yes.
Yes, and let me just try to run this test real quick. So let's do it. Just I want to test it very quick. Maybe just set it for the duration of 5 seconds to get a better view of what happens. So it runs pretty quick. And there you go. So we have one virtual users. So all the things that we checked for, as you've seen in the script, are green because correct messages are produced and consumed. And at the same time, you see that. Let me check. So there are no errors. So the threshold just passed here. And also there are no errors in the reader. So no errors in the writer and the reader. And let me just check real quick. Yes, we have 36,200 messages produced, which roughly accounts for 7,000 messages per second, which is a lot, I would say, for a small test. There are tests. I usually test this from time to time to see the performance. And I think the last time I tested this, I was able to, for 1 minute and 50 virtual users on my machine, on the same machine I used to develop this, I was able to produce 4 million messages with 62,000, almost 63,000 messages per second, which is quite big.
Yeah.
For testing something locally. Yes, that's basically it. Maybe I can show you a little bit more of the scripts. So there are scripts for testing bytes. If you're interested in, you have to explicitly change things. You have to explicitly deserialize. So string from character code. So it's all explicit. You can test this with Avro. So there are a few other things involved when you're dealing with Avro schemas. So for example, I have an Avro schema for the key and also for the value here. So the key is an SSN, social security number, and the value contains first name and last name. And for this, I've also imported a few other constants. I also set a topic, the usual writer, reader, and connection. But here, the schema registry has an object, and the object points to the schema registry URL. So when I run this, it creates binary data that is, serialized by Avro, and then publishes it to Kafka, and then consumes it back, deserializes by Avro bytes, and then converts it to JSON and give it back to you. Yeah.
Now, I know somebody in the comments had mentioned something about protos. So do you have protobuf support from the schema registry? Or
I've tried to implement that, but back then it was a little bit hard, and I haven't refactored the extension. But if you can give me a hand, anyone can give me a hand on this, I'd be very happy to review the PR and stuff. But yeah, there's no support for that yet.
Okay.
Yes. For the schema registry, you might see a few other functions that are already documented here. Maybe I can show it to you real quick. So from few versions back, I started writing this index, the TypeScript types document and generate type docs. So you can see all the enumeration classes, interfaces, and all the constant and everything here. So, like for example, when I'm talking about schema types, if you go into it, there are these 5 things. Like for example, the protobuf is just there; it does nothing. Don't set it. But the rest just works, and so on and so forth. If I go back, so you will see a few different methods on the schema registry, like get subject name when you want to get the subject name of a schema that is already published to schema registry without using my extension or without using this extension. If it doesn't exist, you can also create this schema. So you can send this schema to schema registry and set the schema type, the schema itself, and then the subject. This is the same thing. You just pass data schema here. So the schema object is passed to the serialize function as an inside this object, and then the schema type is type Avro, and then you produce the data, and then you consume them back again. Here I set the limit to 20, check everything, deserialize everything, and there you go. And then the rest, the teardown. I can also test that if you want, but yeah, it's basically the same thing. If you have any questions.
Yeah, we are running out of time, but I did still want to get to a question that Julio asked before. He actually had to go, but I still wanted to answer his question. So his question is, hi everyone, sorry for my bad manners. No problem at all. It's not bad manners to ask a question. Greetings from Spain. Hola, bienvenido. Which approach would you take to do an end-to-end test if you have an entry point that is an HTTP REST endpoint? Next, you have some Kafka topics, more services, and all end with a service sending HTTP calls to a third party. I was thinking about using K6 to inject some controlled load, but then verifying the load reaches the other side, maybe with a function in the teardown stage that reads the messages from a webhook. Maybe the approach is not the right one, but I'd like to see what you think.
I think that's possible. I mean, what you're seeing is not like I compiled XK6 Kafka with K6 itself. So you have all the features of K6 plus Kafka. So you can already do all sorts of HTTP, gets and posts and deletes and everything. So all the rest, and CRUDs and stuff. And at the same time, you have the features of Kafka. And if you use version 0.40, you also have access to the new WebSockets, you have access to Redis and a lot of other things. So just feel free to use it. It's just, I think that's a natural thing to do with K6 and also XK6 Kafka, which adds features on top of K6, not remove the features. So that's my take.
Yeah, I think his approach is reasonable. I would also like to stress, though, kind of in addition to what Mostafa's already saying, that Julio is talking about, firing off the load in the beginning and then checking at the end. I would encourage Julio to also check the components in between. And you can, like Mostafa said, you can use things like Redis or, for each component, it would be nice to have some sort of verification, like some sort of touch point, whether that's, the number of messages in the queue or whether that's like something that was put into a database. And but other than that, I would also suggest that you look at the observability side as well. So testing is one thing and verification, but also make sure that you are able to look at all of these things, even if you haven't specifically thought to test for it or verify it.
Yeah.
Exactly. And also you can use Redis as mentioned. So Redis is an experimental module in version 0.40, and you can store some results in Redis so that you can retrieve them later by, I don't know, the Kafka in the teardown or whatever you think is necessary to do your job. So you can checkpoint stuff into Redis, as you also mentioned, Nicole.
Yeah.
Final words from either of you?
Just that I like the phrase there from Gabriel that Kafka is life.
Said it all, you know?
Yeah. So I guess, Mostafa, if they want to contribute, you already alluded to that. I guess they can just
Please.
find the project on the repo that we linked in the description and in the comments.
Yes.
I'm sure Mostafa would be very happy about that.
Absolutely. I created almost there are 17 issues in the issues, and I've added those who I think are good tickets into the project. So please look at that, and I would be very happy to see contribution, to answer questions, and to even have just discussions, to discuss if you have any ideas, if you want to see any improvements, if I don't know, if you're testing something and you want me to know, please do. I'd be very happy, because I've seen that people are using this extension and contributing back to it, and they add me on LinkedIn and they thank me and stuff.
Awesome.
It's very heartwarming. So thank you.
Yeah,
Well,
and actually at CrocCon, when we were just at CrocCon, we had, I put together a slide on some of the most popular extensions that we've discovered that people are using. And Mostafa, you are number one with the XK6
Wow.
Kafka. So, yay,
Nice. Good job, Mostafa.
Thank you.
Well,
Thank you.
my final words are, we're hiring.
Oh, the
If
shameless
you
plug.
want to join an awesome team that's building cool things together and just enjoying working with each other together, and also on our personal projects on the side, like this project that Mostafa is working on was something that he created separately of K6. Please join us, look at our job ads, because I think we're particularly looking for a Go developer, among other things.
And also backend
also-
developers.
Oh, and backend developers. Okay. And next week, we're going to have Marie Drake on. I think our newest member, possibly. It changes every day. To talk about her week of load testing using XK6 browser. Thank you both for joining me again on a Friday afternoon. And thank you to everybody who watched this.
Thank you.
Have a good weekend, everybody.
Have a good weekend.
Bye, everyone.
Bye.